other things, if there's no other questions about this. All right.
Well,
Yeah.
what's in the drug itself, by the way?
It's an ASO. So an
Ma-
antisense oligonucleotide. So it's to go after in that production process from DNA to protein, to interfere with that.
Okay. Synthetically made?
Synthetically made.
Yeah.
Yeah. Originally, but Ionis has done a few ASOs. Those ASOs that I showed at the beginning, Ionis was involved, I think, in at least 2 of those. It might be more, but they have a long history of being involved in antisense oligonucleotides, ASOs.
Thank you.
Okay, but that's not the only approach. So Voyager Therapeutics, this is the outside of a virus, an altered virus essentially, and so they're going through a different approach to deliver different types of genes to the cell to get at not the RNA part of it, which is where the target for Wave and Ionis is, but the DNA. So can you deliver DNA through a virus, change the DNA of a cell that's producing abnormal Huntington, and make it produce normal Huntington, or at least stop the abnormal Huntington? So that's what Voyager is, their idea is in terms of developing. Now they are also getting, I know that they are getting ramped up and developing their human-based clinical trials. They're also getting started in Parkinson's disease, and there's extensive experience in Parkinson's disease in terms of what they are developing for that. So take a look at Voyager, not just for Huntington's, but what they're doing for Parkinson's, so that Parkinson's can lead the way for Huntington's disease. But this is a DNA-based alteration of the gene and a different way to address the underlying disease process. And then uniQure is a company that's got 2 bases. One is here in Boston, the other is in the Netherlands, and they also have a different gene-based intervention, basically, to get at the production or reduce the production of the abnormal mutant Huntington. So this is, again, look out for uniQure in the news, because they're also developing their program and getting papers published and putting information out, which is usually a good sign in terms of getting ready for human clinical trials. And this is the other technology that often gets talked about, is CRISPR-Cas9. And this literally showed up on my Google News Alert today. It was published a few weeks ago. But CRISPR-Cas9 is a relatively newly discovered natural technology where our bodies go in and cut out genes. It's a natural process that happens. And we think that we might be able to alter this process in terms of the natural and use it to our advantage. Wouldn't it be great if you could go in and cut out, if you had a CAG repeat of, say, 50, cut out 30 of them and make it 20. Or cut out that abnormal part of the gene altogether. So these are the possibilities that are being explored, and it's completely exploratory at this point. There's nothing even close to human clinical trials, particularly Huntington's disease at this point. But this was a paper that was published just a few weeks ago looking at basically a cell-based model of Huntington's disease and using this technology to cut out the abnormal expansion. So we're getting there. We're close, and this is, Huntington's disease is often talked about as one of the best and first and earliest potential uses of CRISPR-Cas9 technology. So this comes up a lot as well. I think that's all I had in terms of data, but people ask, well, what can I do? And I think we've already covered this. You can participate once things are out. We talked about the Roche, uniQure, Wave, and Voyager. Vaccinex is out now. It's a different approach. It's not a gene-based approach, but it's more of an immune-based approach. Enroll HD is an observational study. We hopefully will be a site up and running soon at BI. We've jumped through many of the regulatory hoops, which can be overwhelming for many places, but hopefully we'll be up and running. And that's a platform to get into and connected with a lot of the other studies. I think touched on advocating through HDSA and connecting with the FDA when needed. And these are this is what people talk about and think about in terms of RNA, DNA, changing the gene kind of approaches, but I don't think that we should forget that people that are symptomatic today, we need to address their symptoms, and there are other approaches and symptomatic therapies that are in development and in human clinical trials or about to be screened now. So I think that there's a lot of exciting stuff that has happened, that is happening, and will happen. And I